Today we're going to talk about the dynamics of an airplane in flight, which describes how an aircraft behaves, how it stays stable, and how it responds to pilot inputs. Let's begin with stability. Airplanes are designed with both static and dynamic stability. Static stability describes the aircraft's response to a disturbance. With positive static stability, the aircraft naturally returns to the original position. With negative static stability, it continues moving away from that position, increasing the risk of loss of control. Finally, neutral static stability means the aircraft will just remain in the disturbed attitude, with the pilot having to fix the disturbance manually. Dynamic stability is what happens over time after the disturbance. Positive dynamic stability means any oscillations gradually decrease and the aircraft returns to stable flight, while negative dynamic stability means oscillations continually grow. This makes aircraft control more difficult. Finally, neutral dynamic stability means the plane will stay in disturbed attitude without pilot correction. We look at stability in three axes. Longitudinal stability, which is stability in pitch, is mainly created by the horizontal stabilizer. It helps keep the nose from pitching up or down too easily. Lateral stability, which is stability in roll, is supported by the wing design. Features like dihedral wings help the airplane roll back toward level flight after being disturbed. And directional stability, which is stability in yaw, comes from the vertical stabilizer, allowing the airplane to point into the relative wind like a weather vane. Now let's talk about controllability and maneuverability. Pilots control the airplane using the ailerons for roll, the elevator for pitch, and the rudder for yaw. These controls allow the airplane to rotate around its three axes. A maneuverable aircraft responds smoothly and predictably to these inputs, which is especially important for training environments. One important concept is adverse yaw. When the pilot uses ailerons to roll into a turn, the rising wing creates more drag, causing the nose to yaw in the opposite direction. To correct this, pilots use coordinated rudder along with aileron input, creating a smooth, balanced turn without skidding or slipping. Finally, pilots must avoid over-controlling, which can lead to something called pilot-induced oscillation, which happens when control inputs are too large or too quick, causing the airplane to pitch or roll back and forth in increasing swings. Smooth and measured control prevents this and keeps the aircraft stable. Understanding the dynamics of an airplane, its stability, control, and coordinated movement helps pilots anticipate how the aircraft will behave and manage it safely through all phases of flight.
To continue learning, be sure to subscribe. Thank you for watching.